where we left off here. Oxidation of alkenes, a couple of slides left, and then we can move on to alkynes, chapter 9. Okay, so another reaction for oxidation of alkenes is ozonolysis. Now, this one over here is another reagent called permanganate. You don't need to know the mechanism of this oxidation. You just have to know that you have an alkene. If you add this reagent, permanganate, potassium MnO4, potassium permanganate, if you add that reagent, it seeks out these alkenes and it does a specific oxidation reaction with them. Okay. So here is a terminal alkene. You add this permanganate acid, and what happens is it cleaves this double bond. It oxidizes it up all the way to the acid. Okay. Now, if we're talking about oxidation, you have these a terminal alkene here. If you oxidize it up one level, there's several levels here. You do one oxidation level, you add the two diols across it, right? The cis diols. What was the reagent to do that? The osmium tetroxide, right? You have the alkene, you add the osmium tetroxide, you do one level of oxidation on that alkene, you make it a single bond, and you put two OH groups off of it, a diol, two alcohols, and they're syn to each other. They're either wedges or they're dashes, but they're on the same side. Okay, that's the first level of oxidation, the osmium tetroxide. Now, if you have an alkene, what's the next level of oxidation? That's the ozone reaction. You have the alkene, we add the ozone. It forms this little ring around it. You don't need to know the mechanism. And it cleaves the double bond and puts oxygens there. So therefore, if it's an alkene, you're going to get either ketones or aldehydes, depending where it is. So this reagent right here is terminal. If we cleave it right here with the ozone, we'll get to the permanganate in a second. With ozone, you cleave it right here, you're going to end up with an aldehyde here and an aldehyde here, correct? Because it's a terminal one. Okay. Aldehyde. So that's the next level of oxidation. First is diols. Next level is breaking it and putting one oxygen there. It's going to be either a ketone or an aldehyde, depending on the symmetry across that double bond. Now the next level is the one we're talking about here, permanganate, where it has a double bond. It cleaves it. It goes up to the carbonyl group, the aldehyde or carbonyl, or ketone, and then it keeps on going, goes all the way up to the acid. Okay? So it's a very strong oxidant. So here's this permanganate. This is a terminal double bond. It breaks it. You're going to get the C double bond OH here. And then this is going to cleave here, and it's going to go all the way up to the CO2. Okay, for terminal. That's all it is for permanganate. Everybody okay with that? Know the levels. Alkene, ozonolysis, what does it do? Alkene, osmium tetroxide, what does it do? Alkene with permanganate conditions, what does it do? Breaks it and oxidizes it all the way up to the acids. Okay, now, the key is, that we talked about in the tutorial, can you do this backwards? That's the key. Can you do it backwards? That if you see two carbonyl groups here, you know that they could have formed, or they could have come from an alkene from those two carbonyl groups. Okay, that's where it came from. Right? This type of molecule here, you have a carboxylic acid, well, CO2 is kind of extreme here. If you have a carboxylic acid and a CO2, and I'm like, well, where did this come from? You're like, well, I don't really know any reactions with carboxylic acids that much, except that they're acid or CO2. I don't know any chemistry really there. But knowing the few chapters that he's going to test us on, as alkenes, that it probably came from a combination of these things together, and it was an alkene, and then we add permanganate to break it up. Okay, you have to be able to go backwards too. Okay. Here's another reaction here. There's a proionic acid, HiO4. So what does this do? You already start with a diol. Okay? You already start with a cis diol. Are these diols trans? No, they're cis. They have to be on the same side of the bond, same side of the ring in this particular case. It's a cis diol. Now, is this an alkene? It is not an alkene. It is a cis diol. Do you know that this cis diol, can you go backwards? What did it come from? came from, most likely, an alkene here. That's like this, and we added what reagent? From this to this, what reagent did we add? Osmium tetroxide. Now remember, osmium tetroxide can make the diol as a wedge in this particular case, and it also can make it as a dash on the other side. They're only showing the wedge one. Okay. Just imagine we had the alkene, we did the osmium tetroxide, we generate both, but somehow I select for, I'm able to separate them out and only use the wedge one. Now I'm starting this reaction with the wedge. Okay? So here's the diol here. Now this reagent, the periodate, what does it do? It binds to the cis diol, cannot be trans, has to be cis. It binds to it to form this type of intermediate. That's why it has the brackets. And what it does a rearrangement. This goes over here, this goes over here, and that goes over there. And it oxidizes up these diols. It basically breaks this bond here and forms an aldehyde and a ketone here. Everybody okay with that? It's just a cis diol. You just oxidize it up to the next level. With an alcohol, the next level is a carbonyl group. This has a methyl group off of it, so this one becomes a ketone. This has an H off of it, therefore it becomes an aldehyde. That's it. Okay. If you have a cis diol, you add periodate, it binds to it, does this little rearrangement, it oxidizes it up from an alcohol, OH group, to a carbonyl group. Okay, there it goes, right here. Now, it stops it at this first oxidation. Alcohol to the carbonyl group. It does not keep on going up to the carboxylic acid. Does everyone believe me? You see it, right? It stops at the carbonyl group. Now, we use this carbonyl group all the time. You know that a carbonyl is the umbrella term for a ketone or an aldehyde. Right? Aldehyde, ketone, C double bond O. The umbrella group is a carbonyl, which talks about ketones and aldehydes. Okay. This is the aldehyde, this is the carbonyl here, just because of how it's arranged. Okay. So if you see a diol and you add periodate, like, oh, this is an easy reaction, it's a cis diol, it's going to cleave it and just make it up to the next carbonyl level. Here and here. Okay. Now the issue is, can you go backwards? If you see a molecule like this, you're like, oh, there's two carbonyl groups in here, I can stitch them together. Right? It probably came from this diol or this alkene. Okay. Does that make sense to everybody? Now, if I wanted to go from this reagent all the way to this reagent, what would I use? I'm starting from the alkene. Start with the alkene, and we want to go all the way to this chopped version to the carbonyl, not all the way to the carboxylic acid, to the carbonyl. So this is the starting material. We want to go right up to here. What reagent would we use? One step. What is it going to go? Ozone, perfect. Right, ozone. You do the ozone, it immediately makes that 3-member ring, 5-member weird ring, it cleaves it and brings it right up to the next level. It cleaves the alkene and makes it into the two carbonyl groups. Okay. The osmium tetroxide, it does not cleave it, it just puts a cis diol there. Right? Cis diol, and then the cis diol you have to add periodate to do this. Okay? You can also go one step here. Depends on your starting material. Okay. And the first reaction of the cis diol is what? Go from here to here. Osmium tetroxide, right? Osmium tetroxide, periodate. This one to go directly over here, ozone. Not a big deal, but you just have to have it organized. And the key is to see it go backwards. If I'm going from here to the diol, then I know that, oh, it would start as a diol, and then I added a periodate reagent. Remember, you might be getting a reaction series, and above the arrow, it's blank, and say fill in the blank. fill in the reagents. Okay? And you're like, oh, okay, no big deal, acid, I have that permanganate, I have that osmium tetroxide, ozone, whatever it